Okay, so in this video, we are going to talk about the inference for mean of two independent populations. Remember in our previous video, we have talked about how to do inference of two groups. So the first step is to identify the type of data, whether it's a paired data or it's an independent data. And in the lecture on April the 1st, we have talked about how to do inference on paired data. Now, in today's lecture, we are going to talk about how to do inference for two independent populations. Do you guys still remember what is independent group? That means the two groups are independent of each other. So it's most likely from a completely randomized design. And the example we have seen is, do Americans listen to more music? You are comparing a sample you collected from people in UK and another sample you collected from people in US. So you can see those two groups, they are two separate independent groups. Those are independent populations. Now, how do we do inference for the mean of two independent populations? Here are some notations. It's the same as the notation that you have seen for one population. It's just now, since you have two populations, you are giving it a subscript. So that's the population mean, mu1, mu2, sample mean, y1 bar, y2 bar, population standard deviation, sigma 1, sigma 2, sample standard deviation, S1, S2, and sample size N1 and N2. Now, the idea is we want to compare the populations by taking the difference in their means. So since this is an independent, those two independent groups, so the parameter we are interested in is mu1 minus mu2. The population difference in means. The sample statistic is y1 bar minus y2 bar accordingly. That's still, this is sample difference in means. So in order to do any inference, a very important thing we need to know is the sampling distribution, right? So here is the sampling distribution for the two independent populations. So the population difference in means will be approximately normal. If both populations are normally distributed, or the sample size is large enough, we use 30 as the rule of thumb. If that condition is met, then the sampling distribution of the population difference in means will be approximately normal with the center at the true value of the parameter mu1 minus mu2. And if the samples are independent, the standard deviation has a formula like this. If we replace this population standard deviation, sigma 1, sigma 2, by the sample standard deviation, S1 and S2, then we will have the standard error with a formula like this. This is going to be used because most of the time we don't really know the population standard deviation. So it's more practical that we use the sample standard deviation to replace the population standard deviation and use our standard error. Now let's see how we could do the hypothesis test. The first step, establish the null and alternative hypothesis. So let's write out the null hypothesis. Again, the null hypothesis is always going to be the thing with the equal sign. Most of the time, this mu null is 0, which indicates there is no difference in means. So the H null is actually essentially as mu1 equals to mu2. The alternative hypothesis, HA, is mu1 minus mu2 greater than 0 or mu1 greater than mu2. This is the first form. Second form, less than sign. Third form, if you have no problem with our handout 10 about the hypothesis test for mean for one population, then these should be very straightforward to you. So this is the first step. Second step, check conditions and calculate test statistic. We will talk about the conditions later on. So the test statistic will be a t-distribution, and it's calculated like this. This is the null value we have seen here, and most of the time this will be 0. Of course, it depends on the context of the question. If the question is asking you, okay, whether the difference between the mean of the two population is 2, then this one will be 2. So, but most of the time it's 0. So this is a t-distribution. The degrees of freedom is going to be a pretty complicated formula. If you want to take a look at the formula, you could read your textbook. The formula is over there. So the approximate way to calculate the degrees of freedom is, it could be n1 plus n2 minus 2, or it could be the minimum value of n1 minus 1 and n2 minus 1. So those are all approximately. We don't really need to, use the exact formula for the degrees of freedom. So in our example and in your homework and in your exam, we are going to use this approximate formula. So it's a little bit different than the exact formula you are going to see in your textbook, but it's easier. So that's about the null distribution. Then we find the p-value. We make the decisions based on the rule of thumb. Then we state the conclusion in context of the alternative hypothesis. These all should be straightforward to you. Then the next thing about the inference is to calculate the confidence interval. And this is the formula you are going to use to calculate the confidence interval. So again, it's the same idea. You are having a statistic plus or minus the margin of error. And how would you find this t critical value? It will be from a t distribution with the degrees of freedom n1 plus n2 minus 2. Again, this is approximately. By knowing your confidence level and the t distribution with its degrees of freedom, you should have no problem finding this t critical value. So now let's talk about the conditions that we've mentioned. The conditions for the hypothesis test or the confidence interval to be valid, they are the same. So first, both samples need to be random. Second, sample must be independent of each other. And both population will need to follow a normal distribution, or the sample size is large enough. Usually we use 30. Okay, so having talked about the procedures and the conditions of the inference, we are then going to see examples in our next video.